So what we are going to do today is we're going to review systems of equations. Okay, so all of this is stuff we've done before, but we're going to review it. Okay, so tell me what, before we get started, tell me what a system of linear equations looks like when you graph it if it has only one solution. Huh? An intersection of what? Yeah. So for one solution, I would have two lines that intersect, and here would be my solution. Right? What if I had no solution? What would that look like? Yeah, parallel lines would be no solution. Okay, what if I had infinitely many solutions? Yeah, it's the exact same line. Infinitely many solutions is exactly the same line. Okay? We remember this? Okay. All right, so I want to determine how many solutions each of the following systems has. Okay? Now, you do have a lot of room to write on almost all the problems except for these first few. So just be wary as you start writing. You might want to write a little small on these first ones. Okay, so I need to figure out how many solutions the systems of equations have. So look at number 1. What do you think we might do to try and figure this out?
X or y. See if they're parallel.
Okay, we could solve for y and get them both in y equals. Do you notice anything about these two equations?
It's like x and x and y and y. They're opposite.
They're not opposites. Okay, in the second equation, we divided everything up here by 3, right? So if I multiplied this whole equation by 3, I would get 3x plus 7y equals 22. What is the true about that one and that one? They're the exact same line. So if they're the exact same line, how many solutions do they have? Infinitely many. Infinitely many solutions. Do you know another name for these two lines? No, not all real numbers. I'll talk about that in just a second. These lines are also called coincident. Okay? Now, I want to address the idea that you might be tempted to say all real numbers. Okay, so I want you to think about it. Here are these two lines, right? They're right on top of each other. Okay, so what that means is along this line, there are infinitely many points, right? Okay, it goes on forever and ever. Between any 2 points, I can always put another point. So there are infinitely many solutions that are on this line, correct? Okay, that does not mean that every point is a solution. Okay, that does, right. So if I had a random point down here, is that a solution to this system? No. So it's not that every point is a solution. It's that there are infinitely many points that are solutions. So even if you are tempted, you cannot say anything along the lines of like all real numbers or something like that. This is the first reason. The second reason is solutions to systems are not just a number, right? They're an ordered pair. They're an x comma y. So saying all real numbers doesn't answer anything for me because I need to know what goes in x and what goes in y. Okay, does that difference make sense? All right, cool. Okay, let's look at the next one. What do you think about that one? Number 2. What are we going to do? Okay, they might be parallel. How can we check? Well, this one's already in y equals, so could I go ahead and get this one in y equals? Okay. So subtract 5x, so I would get 2y equals negative 5x minus 8. Then what? Okay, so y equals negative 5 halves x minus 4. So what are these? They're parallel because they have the same slope but different y-intercepts. So what do we know? No solution. All right, let's look at number 3. 3x minus 7y equals 9, and negative 2x minus 4y equals 1. What are we going to do? Okay, so let's solve this top one for y. Negative 7y equals negative 3x plus 9. Y equals 3/7 x plus, or sorry, minus 9/7. Oh, come on. Sorry, minus 9/7. Okay, now, can I go ahead and solve that next one? Yeah, do I have to? If I look at that and I know that my slope in my first one is 3/7, is there any way that my slope in my second equation is going to come out to be 3/7? No. So unless you do something wrong, right? So this would be one solution. Okay? All right. Look at number 4. How do I check to see if a point is a solution to a system? Plug it in. All right. So I'm going to plug this in for x and this in for y. So I have 4 times 3 minus 6 times negative 10. What am I looking for? Looking to see if it works, right? If it makes a true statement. Okay. Does 12 plus 60 equal 18? No. Okay. So if it doesn't work in one, can we stop? Yeah. And we can say that this is not a solution. But what if it worked in the first one? Yeah, you have to do the second one. Okay? All right, look at that table in number 5. They've used the equations on the left to create this table. How can I use that table to find my solution? I don't even have to. Just by looking at it. Okay, what do you mean by where they intersect? Okay, and if they meet somewhere, what's true about that point? Yeah, the point has to be on both lines. So I'm looking for a point on this table that is on both lines. Okay, that's not a point. There we go. Okay, that is the x value where my y values are the same. Questions? Not in a question like this, no. All right, number 6. Use a graph to solve this system. So that means I want you to graph. Okay, so in order to graph, what do I need to do? Solve for your y equals. Solve for slope-intercept. So please quietly do that. Get both of these lines into slope-intercept form. All right, what did you get when you solved the top equation for y? Good, and what about the bottom equation? Okay, let's graph this top one first. What's our y-intercept? 3. What's our slope? Okay, so what does that mean? Down to right 1. Last try. Hey! Okay, so there's my first line. Okay, let's graph my next line. What's my y-intercept? 3. And what's my slope? Okay, so up 1 over 1. All right, what do you notice? Okay, so what's our solution? No, what is the solution? 0, 3. You can, but be careful with what the instructions say, because if this was the instructions, I would be grading the graph. Okay? Okay, we okay? All right, let's review substitution. All right, substitution means we're going to solve one of my equations for a variable and then plug in to the other equation. Yes? Yes. Okay. You always want to pick strategically. Make your life easier when you can. On number 7, which variable should I isolate? Which variable should I solve for? Y in which equation? The second one. Makes it a lot easier to do it in this one. Because there's no coefficients. It's just going to, what's all I have to do to solve for y here? Yeah, so it's just going to be 9x plus 1. All right, once you get y by itself, you're going to take it and plug in for y in the other equation. So I'm going to have 2/3 x plus 1/3 y, and y is now represented by 9x plus 1. So I get 2/3 x. What's 1/3 times 9x? Plus 3x. Plus 1/3 equals 2. Okay, how could I think of 3x as a thirds? No, I need to be able to add it to 2/3. 9/3. So 2/3 x plus 9/3 x. 11/3 x equals, I got to subtract 1/3 from both sides. Could I think of 2 as 6/3? Okay, so 6/3 minus 1/3? 5/3. Okay. I want to get rid of 11/3, so what do I multiply both sides by? 3/11. What can I do with these two 3's? Cancel. So I get x equals 5/11. We are not done. Why not? Yeah, now we have to plug back in and solve for y. All right, so I'm going to come up here. Y is equal to 9x plus 1. So this is 9 times 5/11 plus 1. 9 times 5/11 is? Okay. How could I rewrite 1? 11/11. So 45/11 plus 11/11. All right. So then I'm going to write my answer as a solution point. 5/11, comma, 56/11. Questions? So this will be a calculator portion and a non-calculator portion. So on application type problems or problems with really gross numbers, yes. Problem like this, no. Yeah, you can do that. Okay, let's look at number 8. 3x plus y equals 3. 2 plus y equals negative 3x. Okay, I want to pick the easiest one to solve for. So I think we should solve for y in either the first or second equation. It doesn't really matter. So let's just go ahead and solve for y in this equation. What would I get? Okay, why do you say it's parallel, Lindsay? Okay, so we've got the same slopes, but I want to go ahead and work through this so we see what would happen. Okay, in case you didn't recognize it. But you are correct. All right, so let's go ahead. Let's go ahead and plug in for y. So I have 2 plus negative 3x plus 3 equals negative 3x. So I can get rid of the 3x by adding 3x to the other side. So I have 2 plus 3, and I add 3x over here. I'm going to get 0, so I get 5 equals 0. When does 5 equal 0? Never. This is never true. So I have no solution. So you might recognize up here that they're parallel, or you might work through, and when you get a statement that's never true, your answer is going to be no solution. Questions on that? Okay. Your instructions kind of got left on the previous page. So if you flip it over, those are your instructions for the next page. Use linear combination / elimination to solve each problem. Now, linear combination and elimination are exactly the same. It's just 2 different names. I use the name elimination more often because that makes sense to me. I'm eliminating a variable. Okay? But I want you to be exposed to linear combination too because you might see it referred to like that in a question. Okay, so in elimination, what you do is you manipulate your equations so that when you add them together, you get rid of a variable. Okay? So look at number 9. I've got 5x plus 4y equals 6, and negative 2x plus minus 3y equals negative 1. At this point, it is up to me to choose to eliminate either x or y. It does not matter. Okay? We just get to choose and go with it. All right? So let's go ahead and eliminate y. What would I need to multiply this top equation by in order to get my y's so that they match up? 3. If we multiply it by 3, what's our end goal? What are we trying to get the y's equal to? 12y and negative 12y. Yeah? So when I multiply everything here by 3, I'm going to get 15x plus 12y equals 18. We okay on that? All right. What should I multiply this bottom equation by? 4. So I'm going to get negative 8x minus 12y equals negative 4. I'm sorry? That answer your question? Okay. All right. Now that I've got this set up, I'm going to add down by my columns. Okay? I'm going to add these. So 15x minus 8x, what's that going to give me? 12y minus 12y equals 18 minus 4, 14. So what is x? 2. Okay? What do I do from here? Okay, so I'm going to plug it in. Does it matter which equation I plug it into? No. I would recommend, however, that you plug it into one of your pre-manipulated equations. Because in case you made a mistake, you're more likely to catch it that way. Okay? So I'm going to get negative 4 minus 3y equals negative 1. So minus 3y equals 3. So what does y equal? Negative 1. So how do I write my solution? to negative 1. We okay? It's nice to review things sometimes. Okay, let's look at number 10. It looks equally simple to eliminate x's and y's in this case. So let's go ahead and eliminate our x's. What would I need to do? Multiply the top by what? Not negative 2, because this one's already negative, right? So just positive 2. So I would get 6x minus 4y equals 10. Do I need to do anything to the bottom equation? I'm going to get negative 6x plus 4y equals negative 10. All right, let's think about what happens. Negative 6x plus negative 6x, that cancels. Negative 4y plus 4y, 0. So we have 0 equals, what is 10 plus negative 10? 0. When does 0 equal 0? Always. So what do you think our answer is here? Infinitely many solutions. Yes. It could be any true statement. It doesn't have to be 0 equals 0. It could be any true statement. Okay, in numbers 11 and 12, you are working to solve for a specified value. So in 11, you're solving for y, and in 12, you're solving for y minus x. Now, you might be partial to elimination or substitution, but I want you to look at how it's set up and see if one makes more sense than the others. Okay? When you finish, be sure you check your work. Okay? In each of these, how could we have checked that we got the right solution? Plug it back in. Okay? So on your own, I want you to work 11 and 12. Go for it. Okay. On number 11, you should have gotten your solution points to be 3, -4, but specifically it asked you for y, so y equals -4. All right. On number 12, you should have gotten the solution point 1, 4, but it specifically asked you for y minus x, so you should have gotten 3. Questions? On which one? Okay, what'd you use? Substitution? Okay, on number, guys, hush. On number 12, I would recommend using substitution because I already have y kind of by itself. So I would rewrite this as y equals 4x. Then I would plug that in right here. So I would have 2x minus 3 times 4x equals -10. 2x minus 12x equals -10. -10x equals -10, so x equals 1. You see it? Then I would plug my 1 back in, and y equals 4x. So y must equal 4. Okay? All right, let's look at number 13 together. In last night's basketball game, Joe scored 2 3-points. Joe scored 2 3-point goals. He can't remember how many free throws worth 1 point each or how many field goals worth 2 points each he made. The scorekeeper said he scored 20 times for a total of 34 points. I got to figure out how many free throws Joe made. Okay, on problems like this, part of what I'm grading is your ability to write a correct system of equations. Okay? So I don't want you immediately to going to guessing and checking. Okay? I'm looking, can you write a system of equations? All right? So the first thing I need to do is define my variables. First thing I need to do in a word problem is define my variables. So I'm going to let x equal my free throws. And y equal my field goals. All right? Ideas for one equation in our system. Sean? All right, so tell me where you got that. So we subtract 6 points from the 34 points to get our 28. Good. Yep. And each of these represents the number of points per shot. Awesome. Ideas for the second equation? No. Yep. Okay, the 28 comes from the fact that he scored 34 points total, but 6 of those points were from his 2 3-pointers. So we went ahead and subtracted it. You could have wrote this as 6 plus x plus 2y equals 34 and then solved it from there. Okay? All right, we need one more equation. Very good. X plus y equals 18. Why not 20? Good. It's x plus y equals 18 because 2 of those times were the 3-pointers. Yeah? Okay. You don't understand that?
Time shot. Like he shot 20 times, and you already shot 2 of them.
Yeah, they tell us he shot 2 times already, and we're only concerned with free throws and field goals. Okay? Okay. What do you think is the easiest method to use here? Okay. See, that's the thing about systems. To certain people, substitution is like hands down easier. To other people, elimination is hands down easier. In a couple days, when I show you matrices, you're all going to be using matrices, so it doesn't even really matter that much. Okay? So for now, solve it whichever way you want. I think this is set up nicely for either one. So you pick which way you want. I'm going to give you a couple moments and solve for it. I want you to check yourself when you're done. Remember, with application problems like this, you've got to pay attention to reasonableness. Okay? Could he have shot -3 times? Okay? So make sure you pay attention to reasonableness in these type of application problems. So take a second, solve this, whichever method you prefer. Yes. All right, so raise your hand if you used a substitution. Raise your hand if you used elimination. All right, let's work this with elimination. Raise your hand if you eliminated x. Okay, and who eliminated y? All right, we're eliminating x. Okay, so I'm going to multiply my top equation by -1. So I'm going to get -x minus 2y equals -28. And then x plus y equals 18. Add down. -x plus x, those cancel. -2y plus y. -y. -28 plus 18. It's -10. So what is y? 10. I'm going to plug back in. X plus 10 equals 18. So what's x? 8. So my answer is what? 8 free throws. Okay, I am looking for these units on each problem. Okay? All right, your homework is out of the book, and I'm going to project it for you so you can get started. You've got about 10 minutes. Okay? Here's one piece of information about your homework. On this section, 23 and 25, where it says classify each system, don't worry about that. That's vocab from the book that we're not really focusing on. So just go ahead and determine the number of solutions. Okay?